We're still continuing State Standards 16 and 17 as we work our way through Chapter 9, Section 5, looking at hyperbolas in general form. And again, you need to recall that all the conic sections in general form start out ax squared plus by squared plus cx plus dy plus e equals 0, which means don't forget to get everything on one side and 0 on the other side. For it to be a hyperbola, the coefficient of x squared, the coefficient of y squared must have different signs. Translation, one of them is positive, one of them is negative. Whether they are opposites of each other, like positive 5 and a negative 5, does not matter. Or whether they are different signs, different numbers, like positive 5 and negative 7, it's still the case that they have different signs, so that's what makes it a hyperbola. So as we look at this, we're going to continue with our process of completing the square. Let's get the x's together, get the y's together, take the constant over to the other side by adding 4. We're going to complete the square. We do have coefficients of 1 in this case for x squared. For y squared, we have a coefficient of negative 1. So we need to factor out that negative 1. So negative 1 factored out from y squared is positive y squared. Negative 4y factor out of negative 1 is positive 4y. Alright, we're going to make these perfect square trinomials inside the parentheses. So x is 2-step. 2 divided by 2 is 1. 1 squared is 1. There's nothing in front of it to distribute it by, so do not forget to add 1 to the right side of the equation to keep it equivalent. Then here, 4 divided by 2 is 2. 2 squared is 4. Be careful though, because that 4 is being distributed by a negative 1. So I'm really adding a negative 4 to both sides. We have our perfect square trinomials. That'll factor as x minus 1 quantity squared minus y plus 2 quantity squared, and it does equal 1, and that's what we need for our hyperbolas to equal 1. Now that we've got it in standard form, you're saying, well, where are a and b? Where are the denominators? So let's just pretend we're dividing everything by 1. The denominators are really 1. So that's where we're going to find out how to get a and b. If the no denominators are there, already equals 1. The denominators are 1. Alright, as we look, the fraction with x in it is not being subtracted. Y is, and that means that this is horizontal. The center is positive 1, negative 2. A is the square root of the denominator from the fraction that is not being subtracted. So the square root of 1 is 1. We're going to go left and right 1. We're also going to go up and down 1 because b is also 1. Left and right 1 for a gives us the vertices. Up and down 1 just helps us get the rectangle so we can get our asymptotes. To find the vertices, remember hyperbola only has 2. We're going to go left and right 1 from the center. Left 1 from the center is 1 minus 1, which is 0. And then right 1 from the center, 1 plus 1 is 2. And those are my 2 and only 2 vertices. C, the distance from the center to each focus, is the sum of my denominators, 1 plus 1, square rooted. Square root of 2 is approximately 1.4. That's going to go left and right, the same way A is, and the same way my hyperbola is going. So to find the foci, we're going to go left and right 1.4 from the center. To go left, 1 minus 1.4 is negative 0.4, and we're not changing the y value. To go right, 1 plus 1.4, that's 2.4, and we don't change the y value. There's the foci. Let's continue on. Eccentricity is c divided by a. Well, c is the square root of 2 for its exact value. A is 1. And as we look at that and just double check, this eccentricity for hyperbola needs to be larger than 1. We know square root of 2 is 1.4. Approximately 1.4 divided by 1 puts us in that category. If we want to find the equations for our asymptotes without graphing, it's y equals plus or minus b over a times x minus h plus k. That's if it's horizontal. If it's vertical, this is going to be the reciprocal, a over b. So let's fill that information in because we know h, k, a, and b. So we can find these. B is 1, a is 1. So b over a is 1 over 1. H is 1, k is negative 2, And again, b is 1, a is 1. We want the opposite of it in this case, though. H is still 1, k is still negative 2. Simplifying that, 1 distributed out is x minus 1. Subtract 2 from that is x minus 3. Over here, distribute out the negative, so that's the opposite of x plus 1. Subtract 2 from that is going to be y equals the opposite of x minus 1. And there's the equations for our two asymptotes. Now, we did graphing in standard form, so I'm going to leave that for here for now, and we'll look at another hyperbola in general form. Probably if this one was horizontal, next one's going to be vertical. Alright, so let's look at our next hyperbola. If we want to find centers, foci, everything about it. Here we go. Everything is on one side, 0 is on the other side. We look at the coefficient of x squared. We look at the coefficient of y squared. They are opposite signs, therefore that makes this a hyperbola. Let's complete the square by gathering the x's together, gathering the y's together, taking the constant to the other side. We're going to complete the square twice. We need coefficients of 1 for the squared terms, so we're going to have to factor those out. Negative 9 factored out leaves me with 1x squared plus 6x. Positive 4 factored out leaves me with y squared minus 2y, and that is still equal to 113. Let's make perfect square trinomials. Texas two-step. 6 divided by 2 is 3. 3 squared is 9. In parentheses, we have a perfect square trinomial. But this 9 is being distributed by a negative 9. So we have to add a negative 81 to the right side of the equation to keep it equivalent and balanced. For y, Texas two-step. 2 divided by 2 is 1. 1 squared is 1. That 1 is being distributed by a positive 4. So we need to add 4 to the right side of the equation to keep it equivalent and balanced. Alright, well, let's factor our perfect square trinomials. So that's x plus 3 quantity squared. This is y minus 1 quantity squared. 113 plus 4 minus 81 is 36. It must equal 1. So let's divide everything in sight by 36. Negative 9 over 36 reduces to negative 1 over 4. 4 over 36 reduces to 1 over 9. 36 over 36 reduces to 1. We have standard form. And we may wish to write the fraction that is not being subtracted first. Many textbooks do that. Many teachers do that as well. So there's going from general form, completing the square twice, which we should be pros at by now, and have it in standard form. From there, since the y is not being subtracted, that makes this a vertical hyperbola. Center, now be careful, don't just grab it from left to right. You're going to take the opposite of the numbers in parentheses, but the number in parentheses with x, the opposite of that is the x value of the center. Number in parentheses with y, the opposite of that is the y value of the center. A is the square root of the denominator whose fraction is not being subtracted. So the square root of 9 is 3. Since it's a vertical hyperbola, we're going to go up and down 3 to find our two vertices. B is going to be the square root of the other denominator. That's 2. That's under x. We're going to go left and right 2. That will not give us vertices, but help us with that rectangle so we can find the asymptotes. To find the vertices, though, we start at the center. We're going to go up and down 3. So there's only 2, again, vertices for hyperbolas. Not going to change the x values, just go up and down 3. So if we go up 3, 1 plus 3 is 4. And if we go down 3, 1 minus 3 is negative 2. There's our two vertices. Let's find C, the distance from the center to each focus. We add the denominators together, then square root it. Using your calculators and rounding it to one place, square root of 13 is approximately 3.6. We're going to go up and down 3.6, just like we're going to go up and down 3 for A, because the hyperbola is vertical. Going up and down 3.6 will tell us the foci. So the x value of the center is not going to change from the foci, but the y values will. So going up 3.6 is 1 plus 3.6, or 4.6. Going down 3.6 is 1 minus 3.6, which is negative 2.6. Eccentricity is c divided by a. C is the square root of 13. A is 3. And if we leave it in its exact form, that's what we have. If you want to estimate it in your head, 3.6 divided by 3 is still larger than 1. It's approximately 1.2. The equations for the asymptotes. If it's vertical, its y is plus or minus a over b distributed to x minus h plus k. So we know what a is. A is 3, b is 2, h is negative 3, k is positive 1. Let's substitute those numbers in. So 3 over 2, the opposite of 3 over 2. H is negative 3, k is positive 1. Simplify that, we'll have our two equations for our asymptotes. So on the left, subtracting a negative is adding. Distributing it out is 1.5x plus 4.5. Adding one more to that is x equals 3/2 x plus 5.5. On the right, subtracting a negative was still adding a positive. Distribute that out as negative 3/2 x minus 4.5. Adding 1 to negative 4.5 is negative 3.5. And that's our look at hyperbolas in general form, taking them to standard form, finding out everything there is to know about them. We just didn't graph them in this exercise because we graphed the ones in standard form.